Here's the problem. The double integral from 0 to 4 from x over 2 to 2 of e to the y squared dy dx. To solve this integral, first we have to change the order of integration because we cannot manually do e y squared. How do we change the order of integration? First we have to draw the bounds, 0 to 4 and x over 2 to 2. Let's draw the bounds. So first, let's draw our x bounds. Our x bounds are from 0 to 4. So here is what that looks like. Here's our lower x bound. That's at x equals 0. And our upper x bound is at x equals 4. So that's this one here. Our lower y bound is x over 2. So x over 2 might look something like this. Okay? So x over 2 hits x equals 4 at, of course, 2. So here the y coordinate is going to be 2. And our upper y bound is conveniently y equals 2. So here's our upper y bound, y equals 2. Here's our lower y bound, y equals x over 2. What we're looking for is the area, the volume under this surface over this two-dimensional region. So the area we're integrating over is this triangular slice. And we're slicing this triangle using vertical regions of dy that we translate via dx. And so what can we do to switch the order of integration? We can put dx before dy. To do that, we have to change the order, our vertical representative rectangle to a horizontal representative rectangle. So that means we have to go from this to this. So this has a horizontal slice dx, and we're shifting it vertically along the y-axis with some factor dy. And so what is our lower and upper bound now? Our lower bound, let's write it down, our lower bound is going to be at this point. That's x equals 0. That's our lower bound. Our upper bound is this function, which is y equals x over 2. But if I solve this now, if I solve this for x, I'll get x is equal to 2y. So our x is going to range from 0 to 2y. And our y value is going to range from 0 to 2. So y is going to range from 0 to 2. With this information, we can now integrate. We're just going to switch the order of integration right here. We're going to write the double integral from, this time we're going to do dx dy. So let's put this one first. 0 to 2, integral from 0 to 2y of e to the y squared dx dy. Now notice, since we're integrating with respect to x first, this term here is a constant because it doesn't include any x's. And so what we can do is just take this whole shebang and put it out. And so if you do that, you'll be left with the following integral. We'll have the integral from 0 to 2 of this thing, e to the y squared. So let me write it down, e to the y squared. And then since we integrated with respect to x, I'll have a factor of x here, dy. Now don't forget, we have to evaluate this with these limits of integration. Thanks for watching this multivariable calculus video. We'll check you out in the next one.